studying group 16th elements. Okay, for group 16th elements, oxygen, next sulfur. Okay, sulfur, today class we are going to see sulfur dioxide preparations and properties and uses. Okay, how the sulfur dioxide prepared by laboratory method and industrial method. Okay, and its properties and its uses. Okay, the first one, normal sulfur is treated with oxygen or air to form sulfur dioxide. Okay, so sulfur react with oxygen to form sulfur dioxide. Okay, the second method, how the laboratory sulfur dioxide prepared. Laboratory sulfur dioxide prepared. Okay, so any sulfite ore, any sulfite salt, sorry, not ore, any sulfite salt. So I am going to take sodium sulfite. Okay, its a formula is Na2SO3. It's treated with dial H2SO4 to form Na2SO4 plus SO2. Na2SO4 plus SO plus H2O. SO2 plus H2O. Okay, right. Industrially, how sulfur dioxide is prepared? Any iron sulfide, okay, FeS2 react with oxygen to form Fe2O3 iron oxide plus SO2. Okay, SO2. Okay, here 2 means 2 to sub 4, 4 Fe2, 4 FeS2 plus 11 O2 plus here 8. Okay, it's a balanced form equation. 4 FeS2, this is iron sulfide plus oxygen to form iron oxide and sulfur dioxide. This is a industrial method. And physical properties, it is a properties, colorless and pungent smell of gas, then easily soluble with water. Okay, so that only, suppose any industrial areas the sulfur dioxide is present excess in the atmospheric air. So suppose in the rain it will comes, what happens? So easily soluble, this all the sulfur dioxide gas dissolved with water, so immediately it will cause the acid rain. Okay, so it is soluble with water. And also this sulfur dioxide gas is at the room temperature, it is liquefied and it boils at 263 Kelvin. Okay, so normal room atmospheric pressure, it is liquefied at the room temperature and its boiling point is 263 Kelvin. And chemical properties, so the sulfur dioxide gas is passing through water, what's happening to produce H2SO3. This is sulfurous acid. One more question, this is sulfurous, what's happening for sulfur dioxide is passing through the water to produce the sulfurous acid. And the sulfur dioxide is easily reactive with chlorine gas. This is gaseous form, this is liquid form. Okay, this is liquid form. Okay, so this is gaseous form, this is also gaseous form to produce SO2 Cl2, sulfuryl chloride. Okay, and the third one, sulfur dioxide easily react with oxygen to form sulfur trioxide. Okay, so 2SO2 plus O2 gives 2SO3. For 4 and 4 plus 2, 6. Okay, so sulfur trioxide. This is chemical properties. And also it is react with, in the fourth one, easily react with alkali. Alkali means sodium hydroxide. React with alkali in the presence of SO2 to produce So Na2SO3 plus H2O, sodium sulfite, disodium sulfate. Okay, so here 2Na, sodium disodium sulfate. This disodium sulfate react with excess of sulfur dioxide, so to produce 2NaHSO3. This is sodium hydrogen sulfate. Okay, so this reactions shows that the reactions it resembled with carbon dioxide gas reactions, because instead of this SO2 gas, the CO2 gas is present, means the CO2 react with alkali to produce Na2CO3. At the same time plus H2O, the excess of SO2 excess of CO2 gas added, what's happening, 2NaHCO3. Okay, sodium hydrogen carbonate it produced. Okay, so the reactions it shows that it is the reaction resembled with carbon dioxide gas. This is for reactor sulfur dioxide reactions with alkali. Okay, and it is a good reducing agent. It acts as a reducing agent. It acts as a reducing agent. Okay, because the conversion of Fe3 plus to Fe2 plus. Okay, ferric to ferrous. So take FeCl3 plus SO2 plus H2O. So the reaction FeCl2 plus HCl plus H2SO4. Okay, so see here, its oxidation state Fe plus 3 oxidation state. This also plus minus 3 oxidation state. For sulfur, this is for each elemental sulfur, it is a minus 2 oxidation state. This O2 in the form, it is a minus 2 oxidation state. Totally it is a plus 4 oxidation state. Okay, here the after it reduced the loss of electron, it gets reduced to Fe plus 2 and here minus 2. Okay, here you see this SO4 2 minus sulfur dioxide, it the loss of electron, it oxidation reactions takes place here to produce H2SO4, means SO4 2 minus, no. So this SO4 2 minus, I am going to calculate the oxidation state for this sulfur. We can consider for S, that is X plus 4 into each oxygen, the valence is minus 2 equal to minus 2. Okay, so the X equal to plus 6 oxidation state. Plus 6 oxidation state. Okay, so here this SO2 act as a good reducing agent. Okay, reducing agent. Okay, so it reduced itself, it gets oxidized. Okay, so that it is called redox reactions. Okay, so sulfur dioxide is a good reducing agent. So what about H2SO4? Because of it gain of 2 electrons to produce, to reduce to this sulfur dioxide, so this sulfate, this plus 6 oxidation state, it shows that it is a good oxidizing agent. Okay, right, and it decolorize, the sulfur dioxide decolorizes the K-monophore, decolorizes the K-monophore solutions. Okay, because of the same oxidation reactions takes place. Okay, so these are the reactions, it is for chemical properties of sulfur dioxide. Okay, and its structure is, what is the structure? It is an angular form. Okay, this is for angular structure. Angular structure, how it is? Sulfur, the lone pair of electron is present, and oxygen, double bond oxygen, 1 2 3 4 5 6 7 8. Here 1 2 3 4 5 6 7 8. Okay, so here 1 2 3 4 5 6 7 8. Okay, so this the resonatic structure, so two canonical forms, we can get the two canonical because this double bond is shifting. Okay, so what do you get? Sulfur, and this double bond is shifting to here, this sulfur double bond with O and this oxygen, 1 2 3 4 5 6 7 8. This 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. Okay, so this is the angular form of the sulfur dioxide structure. Okay, right, and so uses for this sulfur dioxide, here the sulfur dioxide used for refining petroleum and sugar, and bleaching of wool, silk, and disinfectant, and it is used for preservatives. And the sulfuric acid and sodium hydrogen sulfate and calcium hydrogen sulfate. So these are the industrial chemicals, the compounds of sulfur dioxide. Okay, and the liquid SO2 is used as a solvent to dissolve a number of organic and inorganic chemicals. Okay, so that's all, children. Next, we are going to see sulfuric acid, the manufacturing. It is deleted by board. After that, the properties of sulfuric acid and its uses. Okay. Sulfuric acid, the manufacturing of sulfuric acid is deleted. Okay, so properties of sulfuric acid. Okay, it is colorless, dense, oily liquid. Okay, so its a specific gravity is 1.84 at 298 Kelvin. Its a freezing point is 283 Kelvin, and its a boiling point is 611 Kelvin. Okay. So when it is dissolved in water with the evaluation of large quantity of heat. Okay, suppose we are going to prepare sulfuric acid from concentrated sulfuric acid means. So what to do? The sulfuric acid, concentrated sulfuric acid is slowly add into the water. Okay, so because otherwise if a, the care must be taken, கொஞ்சம் கொஞ்சமாக drop wise we can add the acid to the water. Okay, so we can get the dilute sulfuric acid, otherwise the amount of energy heat is liberated. Okay, so this and all, so important thing as we have to going in our lab we have to do. Okay, right. So the chemical reactions of H2SO4 are a result of following characters. What are the characteristics for this H2SO4? It is a low volatility and a strong affinity for water. Affinity for when it is dissolved with water, the more number of H plus ions released. So that acidic character. Okay, so it is a acidic character and a strong acidic character, and the ability to act as an oxidizing agent. Okay, and students, you keep it in your mind, before that we studied sulfur dioxide is a reducing agent. Here the sulfuric acid is a oxidizing agent. Okay, and concentrated sulfuric acid is a very strong dehydrating agent. So what do you mean dehydrating agent? Dehydrating agent means removal of water from a particular substance. Okay, so where it is used here, the dehydrating agent, and thus cause charring of sugars. Suppose cane sugar, it's a formula is C12H22O11 sucrose. So in the presence of concentrated sulfuric acid, what's happening? All the moisture contents is absorbed by this sulfuric acid. We can get the residual, that is black residue. Okay, carbon, charcoal. Okay, and water. Okay, because of the removal, dehydrating means easily this H2SO4 remove the water molecule from the organic substance. Okay, so that only all the gases passing through the sulfuric acid, all the moisture content is absorbed by sulfuric acid, but the gases are not react with sulfuric acid. Okay, so this is a dehydrating agent, point number 1. And hot concentrated sulfuric acid is a moderately oxidizing agent, strong oxidizing agent. Okay, so copper react with H2SO4 to form copper sulfate and sulfur dioxide. The presence of sulfur dioxide, it is the oxidizing agent, the reducing agent. This sulfur, the H2SO4 is a strong oxidizing agent. Okay, so students, you keep it in your mind. Oxidation occurs, that is oxidant, it is a reducing agent. Reducing occurs, that is reductant, it is a oxidizing agent. Okay, so you very well know that oxidation means loss of electrons, but the oxidation number should be increased. Reduction means gain of electron, but the oxidation number should be decreases. Okay, so these are the points you already studied in your 11th standard. So here nothing, the strong oxidizing agent means here the acid is a, you keep it in your mind, the strong, and the sulfuric acid is a strong oxidizing agent, sulfur dioxide is a strong reducing agent. Okay, right. So sulfur react with sulfuric acid to form sulfur dioxide and water, and the metal as well as the sulfuric acid react to both metal as well as non-metal. Carbon is a non-metal to form carbon dioxide and sulfur dioxide and water. Okay. Next one question, why is Ka2 less than Ka1 for sulfuric acid in water? Okay. Ka means it is a acid dissociation constant. This acid dissociation constant only decide the strength of the acid, whether it may be weaker acid or stronger acid. Okay, here the question is Ka2 less than Ka1. Reason, suppose H2 sulfuric acid is dissolved with water. What's happening? It produce H3O, that is hydronium ion plus HSO4, that is hydrogen sulfate. Okay. So next the next step, this hydrogen that time the Ka1, the value it is greater than 10. Okay, the Ka acid dissociation constant value would be very high. Okay, the second step reactions, hydrogen sulfate dissolved with water to form hydronium ion and sulfate only. Okay, less than compared to the previous one hydrogen, the releasing of one hydrogen would be less. Okay, so this Ka2 is 1.2 into 10 power minus 2. This is a calculated value, we cannot change anything. Okay, so here the question is, higher the K, keep it in your mind, higher the Ka value, stronger is the acid. Okay, higher the Ka value or lower the pK. Suppose it is a logarithmic value, log value, lower the pKa value, stronger is the acid. Okay, here the larger value of Ka1, that the H2SO4 is the largely dissociated because of, you see here, H2SO4 greater than HSO4. Okay, because this is dibasic acid. Okay, so when it is dissolved in water, more number of H plus ion released. Okay, compared to this to that, it is a dibasic nature, so that this H2SO4 is a greater Ka value. Okay, so greater the value of dissociation constant, stronger is the acid. Okay, so these are very important questions every time. Okay, one sure 1 mark or 2 mark this question will ask. Okay, right. Next, so the same time the con H2SO4 is added to calcium fluoride, so to form calcium sulfate, CaF2 plus H2SO4, CaSO4, calcium sulfate and hydrofluoric acid. Okay, so next we will see the uses of sulfuric acid. Acids of sulfur. Sulfur forms more number of oxoacids like sulfuric acid. Its a formula is H2SO4. Okay. The drawing is draw the structure question. Every year board will ask you one question from this topic. Draw the structure of any H2SO4 or else H2S2O7. Okay. Listen, here H2SO4 means sulfur and the OH double bond O. Okay, here there is no unpaired electrons, lone pair of electrons present. Okay, this is dibasic acid. Okay, sulfurous acid H2SO3 is the formula. Here OH and a double bond with O, yeah, the lone pair is present. Okay, so in case the structure will be a lone pair is present, you must note this, the lone pair and where the double bond connections takes place, where the single bond connected with the sulfur. So everything is very important. Okay, so na எப்போமே சொல்வேன், your name with your initial இல்லாம நம்ம நேம் எழுத மாட்டோம்ல, அதே மாதிரி தான் the lone pair bond pair for a structure, for any structure, when we are going to draw, the lone pair bond pair is very important. Okay, so that only decide the whether it is a pyramidal structure or trigonal plane or the angular structure or tetrahedral structure. Okay, so you must do lone pair is present means you mention the lone pair and the bond pair. Okay, pyrosulfuric acid. Okay, here 2 sulfuric acid, the removal of H2O, we can get the pyrosulfuric acid. Okay, that is 2 sulfuric acid, removal of H2O, we can get the pyrosulfuric acid. Okay, so it's a formula is H2S2O7. Okay, and here also double bond S, double bond O, double bond O, OH. The sulfur is connected between one O and double bond O, OH. H2 and S2. Okay, S2 and O7. 1, 2, 3, 4, 5, 6, 7. Okay, that's all. And peroxo disulfuric acid. Okay, these two sulfuric acid is connected between peroxo bond. Okay, so that this name called peroxide bond. Okay, peroxo disulfuric acid. It's a formula is H2S2O8. Okay, and peroxo monosulfuric acid. Okay, this is peroxo, this peroxo bond with monosulfuric acid, H2SO5. Okay, so students, you keep it in your mind. For organic part, IUPAC, we studied IUPAC and the draw the structure for the given organic compound, very important. That is for organic chapters. So the same thing, this is inorganic. The two sure questions will ask every year by board. That is one question from chapter coordination chemistry, IUPAC name. Okay, so and the P block elements, one question, two more question, that is draw the structure of any the group 16th for we are studying oxo acids. At the same time group 17th also we have a draw the structure questions there, and group 18 also. Okay, so you have to do for daily practice. Draw the structures for the given structures, sulfuric acid and pyrosulfuric. Daily structure draw panna abinona, definitely you will get 2 marks. Okay, yes, correct.